A rotation about a fixed point. Called the center of rotation. Through an angle of x degrees that maps a point to its image such that all vertices stay the same distance from the, we're going to call it COR, which is the center of rotation. Alright, a rotation about a fixed point, called the center of rotation, through an angle of x degrees, maps a point to its image such that when you're rotating, all vertices stay the same distance from the center of rotation. All vertices rotate counterclockwise unless otherwise noted. A line drawn from each vertex to the center of rotation and a segment from the center of rotation to the image vertices forms the angle of rotation. So here's what you kind of want to get out of this. If you are asked, let's see, copy ABC and point K, then use a protractor and a ruler to draw a 140 degree rotation of ABC about point K. So let's rotate ABC about K. And they're saying 140 degrees. And let's put a triangle here. Rotate ABC about K 140 degrees. So let's say we've got a triangle ABC. And then right here, let's say we got, let's go right, where do we want it? That would be 180, be over there, 140, about right there. We're going to make this one red, point K. So, there's a couple of ways. Here's the best way to do this. What you want to do is you want to take this shape and you want to rotate it counterclockwise 140 degrees around K. What that means is that every point has to stay, every vertex has to stay the same distance from K as it is right now. And every vertex has to rotate 140 degrees around K. Alright? So, I don't know how good of an imagination some of you guys have or don't have. I don't know if you can picture a circle that goes around K. If you can, that's great. If you can't, well, we'll try to come up with a different technique. If you can imagine a circle that goes around point K and it goes through point B. Can you picture that? Alright. Now, if we went right here, if we cut this circle in half, wouldn't this top portion of the circle be 180 degrees? So if we took point B, and put it over here on the other side of this diameter, that would be a 180 degree rotation. But we don't want 180 degrees. We want 140 degrees. So if you take this circle and you split it in half again, the other direction, now you've got 90 degree increments. And if you break this circle down again right here, these two directions, now you've got 45 degree increments. Y'all see that? So with that, if you rotated point B to right here, it would be 90 degrees. If you rotated B another 45 degrees, if you went this far, that would be a 90 degree rotation. If you went another 45 degrees, now that would be 135 degrees. And they want 140, so they want about right here. So if you take B and you rotate it around K to right there, there's your B prime. And then what you have to do is you have to do the same thing with each vertex. Alright? So there's your B prime. Now you're going to do the same thing with A. So you're going to imagine this same rotation. If you drew a line from, here's your angle now that you're trying to keep the same on all of these rotations. You're trying to rotate them about this far right here. That's about your 140 degree rotation. Okay? So if you can imagine point A rotating around this circle, but now you're going from A, let me do this in another color, you're going from A to K, and then you've got to have this same angle. So we're a little past it, so we got to go a little past it here. So we're probably talking like point A being right out here. So there's your A prime. And then point C. If you draw a line from C to your center of rotation, and then you create a 140 degree angle, it's probably going to be about here. And that's going to be on this circle. So there's your C prime. So when this thing is rotated, here's your new shape. Alright, freehanding it. That's not very good, is it? The key to your rotations is that, again, each point, each vertex from the pre-image to the image stays the same distance from the center of rotation. And then if you drew a line from vertex to vertex, it should match this angle right here, should match this angle. And if you went from vertex to vertex, it should match this angle again. And then vertex to center of rotation to vertex should match that angle. Alright, now the book talks about using a protractor, but we don't have any protractors. So when you've got to rotate these things by hand, you're really estimating the best that you can. Okay? When you're rotating it on a graph and you're going around the origin on a coordinate plane, sometimes it's a little easier because you've got some lines that are on the paper and you can see some angles a little bit easier. Alright, so let's look at page 641 there. Page 641, you got some key concepts. 90 degree rotation, 180 rotation, and a 270 rotation. This is a real good rule here to have in your notes. Okay? So let's look what it says. To rotate a point 90 degrees counterclockwise. So let's say to rotate a point. And let's go counterclockwise. To rotate a point counterclockwise. About the origin. Here's your mapping. To rotate a point counterclockwise about the origin. For a 90 degree counterclockwise about the origin, you're going to take every xy the original y value times -1 becomes your new x value. The original x value becomes your y value for a 90 degree rotation. Okay? So for a 90 degree rotation, if, let's say, point A was at 2, 3. After a 90 degree rotation about the origin, look at what A prime would be. Alright? Your original y times -1, so we'll go -3 would become your x, and your original x becomes your y. So this would be 2. So this would be your A prime. And you would do that with each vertex. Say it again. because that's the rule. You see how in this first set of parentheses, this means for every xy. This arrow means after the rotation. This means my new x value will become the opposite of my original y. And my new y value will stay the same as my original x. Okay? So what it is it's a super shortcut to when you don't have to do all that. Okay? All right. So for a 90-degree rotation counterclockwise about the origin, it's real clean. And here's the second rule: 180-degree rotation, 180 counterclockwise about the origin. All right. For every xy value after the rotation, you're going to negate the original x and you're going to negate the original y. Okay? So now if your point A started off as 2, 3, after the rotation, your new A, all right, your A prime would be at -2, -3. See how the rule works? And then they also give you the shortcut for a 270-degree rotation. And for a 270 counterclockwise about the origin, for every xy value of the pre-image, after a 270-degree rotation, your new x is the original y, and your new y is opposite of the original x. So now for that same A that we had at 2, 3, if we're going 270 degrees counterclockwise around the origin on the coordinate plane, our new x value is the original y, which is 3, and our new y value is opposite of the original x, which would be -2, and that would be your A prime. Okay, does that make sense? It's a mapping rule to kind of, it's a huge, major shortcut. Well, it's rotations, they stick it in one section when you could really spend you could spend 2 or 3 weeks working on rotations, honestly. Because you could spend a whole week trying to trying to picture rotating something around a point. And I mean, it kind of goes back to anytime if you've got a point, and this is your center of rotation, and you've got this shape, all right, this triangle ABC in this case, and I can't do it, and I was going to try to find some videos for you this morning. In your practice today, I'll just give you here's some practice for you today. Page 643. Try number 1. All right, you're going to rotate that triangle around point K, and they're telling you 45 degrees. And then, let's see, multiple choice. No. Look at page 644. Do number 14. And then do 16. Do 14, 16, and 18. Okay? And what you're going to be able to do on 14, 16, and 18, graph each figure and its image after the specified rotation. Don't graph it first. Or you can graph it first if you got graph paper. Okay? The most important thing is that you list the vertices after the rotation. And number 14 is a 90-degree rotation, so you're going to use this rule right here. And number 16 is a 180 rotation, so you're going to use this rule. And then number 18 is a 270 rotation. So you're going to practice using each of these rules, okay? And all of these are counterclockwise because they don't give you a direction. If they don't give you a direction, you're going counterclockwise. All right, so just use that rule 3 different times, 3 vertices on each problem. And this, no, you just got to do number 1. 1 and then 14, 16, and 18. And then what I want you to try to do up here at the beginning, this was your essential question for today. All right. I want you to do those practice problems. Do those practice problems. And then I want you to answer the essential question. All right. Now make sure I really would like you to have all of that done. I want you to work on it until the bell rings. But have it finished when you get to class tomorrow, okay? Because the essential questions are going to start becoming part of your quiz. Got it? Yes.